This question comes from Aisha, who asks, if the sun somehow vanished for exactly 5 seconds and then came back, what would happen? The answer is almost certainly nothing. Start with light. The sun sits about 150 million kilometers from Earth, and light covers that distance in roughly 8 minutes and 20 seconds. This means that everything you see when you look at the sun is already 8 minutes old. The sun you observe right now is the sun, as it existed 500 seconds ago. If the sun were to disappear at this exact moment, you would not find out for another 8 minutes and 20 seconds. You'd just be watching old light from a star that no longer existed. For 5 seconds of disappearance, the light gap would be 5 seconds wide, and it would arrive at Earth 8 minutes and 20 seconds after the event. So from our perspective, there would be a 5-second blink of darkness, but only half a second after 8 minutes of completely normal sky. Nothing on Earth's surface would indicate anything was wrong before that. Now add gravity. It used to be assumed that gravity was instantaneous, that if the sun disappeared, Earth would immediately fly off its orbit. Einstein's general theory of relativity says otherwise. Gravitational effects propagate at the same speed as light. This was confirmed directly in 2017 when the LIGO detectors picked up gravitational waves from a neutron star merger at almost exactly the same moment that gamma-ray telescopes detected light from the same event, matching to within 2 seconds across 130 million light-years of travel. Gravity and light run the same race. So the change in the sun's gravitational field during those 5 seconds would also take 8 minutes and 20 seconds to reach us. This means that on Earth, both effects, the darkness and the gravitational shift, would arrive at the same moment, 500 seconds after the event, as a simultaneous 5-second pulse. During those 5 seconds, the sky on the day side of the Earth would go dark, the moon would go dark, since it only reflects sunlight, and then both would return to normal. Earth's gravitational pull toward the sun would briefly cut out and resume 5 seconds later. That's it, from the perspective of anyone standing on the surface. But there is something subtler happening to the orbit itself. Earth travels at about 30 kilometers per second around the sun. In 5 seconds of straight-line motion, with no gravitational curve being applied, it would drift about 150 kilometers off the precise arc of its orbit. That sounds significant, but consider the scale. Earth's orbit is about 940 million kilometers in circumference. A 150-kilometer deviation is roughly 1 part in 6 million, comparable to a strand of hair's width on a football field. When the sun's gravity resumed, Earth's path would be gently corrected, and the orbit would continue, fractionally elliptical compared to what it would have been, but completely undetectable without instruments of extraordinary precision. The orbit would not be destabilized. Earth would not spiral away or fall inward. It would just be very, very slightly different than it would otherwise have been. There is one more effect worth mentioning, though it would take months to measure. The sun constantly emits a stream of charged particles called the solar wind, which forms a bubble around the solar system called the heliosphere. This bubble deflects a substantial fraction of cosmic ray particles' high-energy radiation from outside the solar system that would otherwise reach Earth's atmosphere more directly. A 5-second interruption in the solar wind would create a small gap in this shielding, but it would take far longer than 5 seconds for any cosmic ray flux change to manifest at Earth's surface. This too would be undetectable. So what Aisha's question really surfaces is something counterintuitive. Because information cannot travel faster than light, and because both light and gravity obey this limit, a 5-second disappearance of the sun is essentially unobservable to anyone not already looking at the sky during that exact 5-second window at precisely the right moment. And even then, it would look like a brief, total solar eclipse, with no warning and no moon in sight, which would certainly attract attention. Scientists monitoring the sun continuously, with specialized solar observatories, would register the event as a sudden 5-second dropout across all wavelengths. The seismographs and gravity monitoring networks built to detect gravitational waves would log a small perturbation 8 minutes and 20 seconds after the optical instruments did, and both readings would be considered, for some period of time, completely inexplicable. The sun would be back. The orbit would be fine. But the physics departments would have a very bad week.